Here we go. Here we go. Beautiful. Okay, that's beautiful. Here we go. All right, so that's just what it means to be simplified. Okay, so we know what it means. How do you actually pull that off? Well, that's what I have here. Really, you just factor the numerator and denominator, and you just cancel any common factors. Mathematically, when you cancel, you're actually doing something like this. You're dividing by that common factor. Okay, so that's what it means to simplify. You factor the numerator and the denominator, then any common factors, you cancel. And a very nice theorem that comes into play. In fact, I haven't really, this is actually the second time I've done synthetic division in this course, and I think I'll keep doing that from now on, because you can see it's very useful to get this factor theorem. Because this is telling us that for any polynomial p of x and any real number a, x minus a is a factor of p of x exactly when, or if and only if it's the same thing, p of a is 0. So another way of actually, we'll apply the factor theorem. So I was about to say something, but then I think it would have been wrong, so I stopped myself. So this is the factor theorem, and this will come in handy, as you'll see. We'll see some examples of this. I mean, basically what's going to happen is, let me go back to, see if I can get to it, this slide. If you, let's say, can factor q of x, right? Let's say it's an easy thing to factor. You can actually check if p of x has those same factors if those factors of q are in the form of x minus a number. And what do? You just do p of that number. And if it equals 0, then this is a common factor. So if the numerator and denominator both map a number a to 0, then they have a common factor. Okay, that might be causing more confusion, so let's dive in and do some examples. So let's say we have this one here. Now I should point this out, the book does it. It will put something like, comma, x is not equal to -2. They'll put that down. Basically, they're assuming that we're working in the domain. That is, we're assuming x is a real number such that this is defined. That is, such that the denominator is not 0. That's basically what we're assuming here. It's just something they will point out. I mean, I'm generally not going to write down, comma, x is not, a number, or x is not, in this case, -2. The book will. But again, all that's saying is we're assuming we're working in the domain. That's all. All right, so let's actually simplify. Well, the denominator is already factored, right? You can't factor x plus 2 down any further. The numerator, you can. Right? We can see that the smallest power of x is 2. Excuse me, the smallest power of x is x squared. So we can factor that out. Notice also that since the leading coefficient's 1, you can't factor out any numbers, except 1 or -1, but that's not going to help. Just like when we were finding the greatest common monomial factor. Okay, so let's factor out x squared. You divide to get what's left over. That's what we're doing here. Well, this quotient is just x. This quotient is just 2. So the numerator can be written this way, by factoring out x squared. And note, okay, so what does that tell us? We can cancel, let me write it out with a pen actually. We can cancel x plus 2. And so what we get is, in simplified form, our rational expression is just x squared. Now, here notice we're actually assuming x is not -2. Because if it was, this would not make sense. You can't have 0 in the numerator and denominator at the same time. That wouldn't make sense. So implicitly, we are assuming x is not negative 2. That's why this equation works. Any questions on that? Okay, let's do another one. We're going to simplify this. Now, here, it may not be obvious what, what we can cancel or if it's even simplified. So let's factor the numerator and the denominator. I mean, these are not that bad to factor, right? We have x squared plus bx plus c, so to say, like we saw earlier in the course, right? And in that case, you want two numbers whose product is the constant term and whose sum is the coefficient of x. I'm just saying how you factor these kinds of quadratics, these kinds of polynomials here of degree 2. So for the numerator, we want two numbers whose product is negative 3. The sum is 2. And what do we get? Well, as you can see on the slide, we have 3 and negative 1. The product is negative 3. The sum, right, if you do 3 plus negative 1, which is the same as this, you get 2. Okay, that's great. What does that tell us? That tells us the numerator here can be written this way. The denominator is the same idea. Namely, we want two numbers whose product is minus 2, whose sum is 1. We have minus 2, right? So we want two numbers whose product is minus 2 and whose sum is 1. Well, how about 2 and negative 1, right? That product is negative 2. The sum is 1. Right? 2 plus negative 1, 2 minus 1, same idea. You get 1. Thus, we get this. Okay, so if we put those in, as you can see, not only you can see what the domain is, right? But in addition to that, we can cancel out x minus 1. And we cancel and we get this. So we have simplified it, right? There was a common factor of x minus 1. We cancel that, boom, we're good. Ooh. Any questions on this? Okay. Here's another one. All right, so let's simplify this rational expression. Oh boy, this looks fun, right? We're going to factor. We basically have to, let's factor the numerator and denominator. Okay, we're going to simplify, so let's try factoring them. Well, for the numerator, right, we can see that x squared, well, actually, we can see that x squared is a common factor, mostly because x squared is the smallest power of x in the numerator and denominator, right? You can see the smallest exponent of x is 2, for both of them. So let's factor out x squared. Doing so, from the numerator, we're going to get x squared times x cubed minus 4x squared over x squared. That's equal to this. When you divide into each term. So here we get x, right? You subtract the exponents. Here we get 4. We get x squared times x minus 4. Here, if we factor out x squared, same idea. We have this divided by x squared, right? Which is dividing x squared into each term. Here, we get 3x squared. Here we have 11x, well, minus 11x, minus 4. Now, basically by some factoring, right? What we got was this. That's wonderful, because now the x squares are going to cancel, and we end up with this. Before we finish it, let me just take care of